All right, welcome everybody. This is Mr. Urbanc. This is our virtual video lesson for section 5.4. So this is also for my three classes and Miss Theo's fourth period geometry. So it's for all you guys. And this is Wednesday night, but I'm recording this for Thursday morning. So you guys are going to do a mini virtual lesson. I'm going to keep this to about under 10 minutes if I can with examples. It might go a touch longer, but it should be pretty short. And then this should set you guys up for the homework that we've assigned. And for my students, it'll be on the website. And then for Miss Theo, wherever you guys normally put your homework assignments, that's where that'll be located. So we're going to begin. What are our lesson objectives for this? So up to this point in Unit 5, we've learned about polygons, we've learned about interior and exterior angles, and most recently you guys have been doing a review assignment covering the 3 coordinate geometry things, which we will use not right away in this lesson, but in this unit, I'd say probably starting Friday. But the key is we're going to be using slope, midpoint, and distance formula. But for this particular lesson, this mini lesson, we have 3 main objectives. Number 1 is we are going to discuss the properties of parallelograms. So we've talked about polygons in general, but now we're going to kind of hone in on a very specific type, and that is a parallelogram. So we're going to find it's pretty useful. And then we're going to try to apply those properties of parallelograms to determine, I don't know why that E is cutting off over there, but that's an E on the end, determine missing side lengths and angle measures. So basically we're going to provide you with information and you're going to use the properties to find anything that's missing. And then the biggest part, and this is where the coordinate geometry is going to come into play, is we're going to talk about how to prove something's a parallelogram using the coordinate geometry. Before we do that, though, we need to do a little vocab review of things we've covered. One of these is new from this unit, and another was actually, the other 2 we pretty much talked about at some point this year. So the first vocabulary term we're going to talk about is what a diagonal is. We looked at diagonals in different shapes and how a diagonal is just a segment that connects 2 non-adjacent vertices. And we learned that any quadrilateral will have 2 diagonals. So you can connect this vertex to this. Obviously, I cannot connect to here or here because those already exist. Those are sides of the shape. Or we can connect this to this. So every quadrilateral, no matter what it is, parallelogram, and all the other ones we're going to learn about today and later this week, they all have 2 diagonals. So we'll come back to that. The second thing is opposite angles, and they're just what they sound like. If you have a quadrilateral, you have 4 angles, and in any quadrilateral, you will have 2 pairs of opposite angles. So here you have angle 1 and angle 3, which are across from each other. So we call those opposite angles. And then same thing with angle 2 and angle 4. So the 2 pairs of opposite angles are 1 and 3, 2 and 4. And then we have consecutive angles. So consecutive angles are just angles that are, you can think of them as being adjacent to each other. So they share a common side. So for example, angle 1 and angle 2 are consecutive angles. Angle 2 and angle 3 and angle 4, and angle 4 and angle 1. And so you have 4 pairs. And remember, this video, you can pause it at any point in time if you need to write stuff down, or if something I said didn't make sense. Remember, you can always listen to it a second time. So what I want you guys to do, now if you watch this video straight through, I would ask that you pause it. So right now, I would like for you guys to take 3 minutes. I'm not going to waste 3 minutes in the video, but I would like for you to pause the video when I'm done speaking right here. And there are 7 different classifications of 4-sided polygons. So we call any 4-sided polygon a quadrilateral. There are 7 other names of quadrilaterals, and I'd like to see how many you can come up with in 3 minutes. So go ahead and pause the video. And again, if you don't, I'm going to pause for about 10 seconds until you do that. But see in 3 minutes how many of the 7 remaining quadrilateral classifications you can come up with. Okay, so if you paused and unpaused, or if you just watched this straight through and came back because you didn't want to waste time. So the 7 other ones, so we have 8 different types of 4-sided polygons. The first one is a quadrilateral. The second is something called a kite. And it is not one of the more common ones we do, but basically the shape of a kite looks something like that. So you have these 2 sides are equal to each other, and the ones on the bottom are equal to each other. We have something called a trapezoid, which you're familiar with, hopefully. That's a shape that looks a little something like this. And I drew that uneven on purpose because the fourth type is actually something called an isosceles trapezoid, which we'll talk about a little later. And then I'll kind of pop through the last four quickly because these are the four big ones. That's why I put a line right there, is parallelogram. And a parallelogram is unique because it is the only four-sided polygon that gets its own shape. So when you label something as a parallelogram, you actually label it with this little shape right there, and then you call it A, B, C, D, or whatever the vertices are. So it is the only one that gets its own shape. And then the three remaining ones we've talked about at some point in time, especially when we talked about regular polygons. You have a rhombus, which is an equilateral quadrilateral. You have a rectangle, which is an equiangular quadrilateral. And then we have a square, which is a regular quadrilateral. So it's equiangular and equilateral. And so we're going to focus our attention. This is kind of a flow chart. You don't have to memorize this right now, but it gives you a breakdown of how all these shapes, all these 8 shapes, the quadrilateral, the kite, the rhombus, all of them, they're actually interconnected to each other. They share common properties. And so we're going to find out how these properties connect and flow between the shapes. And we're going to focus most of our attention initially on these 4 shapes. So the parallelogram, the rhombus, the rectangle, and the square, because they are the most useful. And for this lesson in particular, you're going to focus all your attention on a parallelogram. Because if you can learn the properties of a parallelogram, we're going to find out that all those properties filter down to a rhombus and a rectangle and eventually a square. Now, if we were in class, I would have you guys pass a piece of paper that had a drawing, and you would see quadrilateral LAMB, so quadrilateral LAM, and I would have you guys measure the lengths of the sides and use a protractor to measure the angles. Since we are not in person, that's not really possible here. We're just going to go through the 5 properties of a parallelogram, and these are the properties you will have to memorize. We will not let you use a study guide for this or a cheat sheet. You need to know these because they are extremely important. So property number 1, and I'll try to color code this diagram for you. Property 1 is that both pairs of opposite sides are parallel. That kind of makes sense because the name of the shape is a parallelogram. So obviously the opposite sides are parallel. And if you don't remember from our second unit of the year back in September and October, we learned that if you want to say that 2 lines are parallel, you use the arrow tick marks. So I'm going to put 2 arrows on each of those, and then I'm going to put 1 up here. So the top and bottom are parallel to each other, and then the left and the right are parallel to each other. Okay, and that is property number 1. Property number 2. So not all these properties are difficult. Some of them are just kind of obvious. Property 2 is that both pairs of opposite sides are congruent. When I think of a parallelogram, I think of a rectangle that's been blown over. So take that rectangle and imagine it's blown over. It still maintains some of the properties of a rectangle, but it doesn't have the right angles that a rectangle does. So in this case, both pairs of opposite sides are congruent. So we're going to use our congruent tick marks to label those. And that's property 2. Property 3 is that opposite angles are congruent. So this is why back here we talked about opposite angles, because when we're talking about properties, we need to be able to identify consecutive or opposite angles. So in this case, let me get rid of those again. So property 3 is that opposite angles are congruent to each other. So that's angle B, which we'll put 2 tick marks here, and angle A. Those are opposite angles. And then angle L and angle M are opposite angles. And that's it. Property 4, consecutive angles are supplementary. Now this is one I'm not going to put any tick marks on because there is no tick mark for supplementary, but we do know that consecutive angles would be, for example, angle M and angle B, because they are next to each other, they share a common side. And one of the reasons why this property works actually goes back to property 1 that says that both pairs of opposite sides are parallel. Well, if you remember back again in unit 2, we talked about that if you have 2 parallel lines and then a third line called a transversal that goes through it, these angles right here that we're calling consecutive angles, we used to call them same side interior. And if you don't remember, same side interior angles are actually supplementary to each other. So this right here goes all the way back to property number 1 and links back to the stuff we did all the way back in September. So consecutive angles are supplementary. And then the 5th one is going to take a little bit time to wrap your brain around. It says that the diagonals bisect each other. So we said that every quadrilateral has 2 diagonals. So this is diagonal number 1 and diagonal number 2. What we're going to find is if this is a parallelogram, those 2 diagonals actually cut each other in half. So that would mean, now we don't have a point here in the middle, but we'll eventually label that these two segments on either side are congruent to each other. And then since I've already used 1, 2, and 3 tick marks, remember we don't want to use 4 or more, it just looks awkward. I'm going to go ahead and put a circle here and a circle here. So the two diagonals in a parallelogram cut each other in half. So if you are comfortable with those, you can actually stop watching the video and attempt the homework, which is posted on my website and wherever. If you still feel a little iffy, or if you want to see some examples, I'm going to go ahead and walk you guys through 2 examples. And so on this slide here, this is just the 5 properties. One of the little tricks you can use to memorize these is of the 5 properties, 2 of the properties are related to sides, 2 of them are related to angles, and then 1 is related to diagonals. So that may or may not help you guys remember all 5 properties there, but definitely something you want to memorize. So example number 1. So we've got properties of parallelograms. I've got them listed over here to the right. And you have to decide which ones apply to which problem, because you're not always going to use all 5 properties in any given problem. The first question I have here, though, is how do you know that this is actually a parallelogram? Because it's not labeled, it doesn't have the parallelogram marking like we said, remember the symbol, and I don't specifically tell you it's a parallelogram. Well, if you look closely, you can see on the top and bottom and left and right, they've provided us with the arrows. They're actually telling us property number 1. That says that both pairs of opposite sides are parallel to each other. So those red markings, even though they're subtle, are actually telling us that we have a parallelogram, which means we can now use all these other properties. So let's look at property 2. Property 2 says that both pairs of opposite sides are congruent. Well, that helps us a lot here because segment AD is congruent to segment BC, which is good to know, but that doesn't really help us because we don't know what's going on with the measurements of those. Does, however, help us because the top and the bottom are congruent to each other. So you'll notice this is a very, very, very simple example. I promise you the homework problems are going to get a little harder. But since the top and the bottom are congruent to each other way, way, way back in the day, that anytime you have 2 segments that are congruent to each other, you can set them equal to each other. So x plus 4 is equal to 12. And then by this point in time, you guys don't need any assistance solving that. X is equal to 8. And so that was one of the values that they asked us to find. And then the other value they wanted us to find, we can actually use the third property. So the opposite angles are congruent. And in this case, I've got angle Y in the upper left-hand corner and a 65 in the lower right-hand corner. And so you can simply say that Y is equal to 65 because opposite angles are congruent to each other. All right, that's example 1. Example 2, and these are problems 9 through 16. This is actually from our Big Ideas textbook. This is not part of your homework assignment because I thought it'd be a little too easy. But I thought these were good problems, again, just to illustrate at a very basic level how these properties work. Now, there are 3 images here. They're the same image. I just created 3 so that I can color code them a little bit and make it a little easier for you guys to follow. So first example, they want us to, now this is a little different than the last one. They are telling you this is a parallelogram. So remember that little symbol that's in front of L, M, and Q tells us that as a parallelogram, which means all 5 of these properties are in play. Again, you don't know which ones, you just got to kind of figure that out as you go. So number 9, they're asking us find the measure of segment LM. Well, LM is along the top here, and property 2 states that both pairs of opposite sides are congruent. So LM would be congruent to QN, which happens to be 13. So the answer to number 9 is 13. By the way, if you want for practice, if you want to pause the video and try these on your own to see if you can get them, that might not be a bad idea. If this was a problem we were doing in class, I would probably give you guys 5 or 10 minutes to kind of work through them. Maybe a little, 10 minutes might be a little much. But I would definitely encourage you guys to try them on your own. So if you want to pause the video now, try to work through 9 through 16, and then I'll go through each one of them and show you guys the answer. Okay, number 10 asks us to find segment LP. So segment LP looks like it's the diagonal, but it's only part of the diagonal. It goes from L to the middle where P is. And if we look at property number 5, property 5 states that the diagonals bisect each other. So I know that these 2 diagonals here and here cut each other in half. And since this segment over here, segment PN, has a length of 7, I know it's being cut in half. So I know that segment LP happens to be the same measurement as well. So it is 7 also. And number 11. segment LQ. LQ is exactly like we did on number 9. LQ is one of the sides. And so since opposite sides are congruent to each other, I know that is equal to 8. Sorry for the dishes in the background. My daughter is putting dishes in the dishwasher. The fact she's actually working, I don't want to interrupt her. Okay, we move on to number 12. Number 12 asks us to find the measure of segment MQ. MQ is the length of the entire diagonal. Now, we don't know what MQ is right off the bat, but we do know that the diagonals bisect each other. And since they bisect each other, this segment is 8.2, which means the segment on the other side is also 8.2. And then if I want the measure of the entire diagonal, I add those two together and I get 16.4. Now, so the first 4 questions there we did segments. Now we're diving into the next 4, which are talking about angles. So this one asks us to find the measure of angle LMN. Now, one of the tricks I like to do with this is we have a quadrilateral, specifically a parallelogram, but has a lot of junk going on there. Sometimes it's better to redraw them without all the junk on the inside. And now if we want to find angle LMN is way up here, and I don't know the measure of it, but I do know the measure of the upper left angle, and that's 100 degrees. So notice they've got the 100 with the arrow. So since this is 100 degrees, we're going to use property 4 that states that consecutive angles are supplementary to each other. So that means this angle up here is 80 degrees, and we're in good shape. And I'm going to go ahead and fill, because I know I'm going to answer this coming up, I'm going to fill in the rest of this parallelogram. Since the upper right-hand angle is 80 degrees, I know that the opposite angles are congruent, so I know the lower left is also 80. And then if the upper left is 100, I know the lower right is also 100. And in fact, that's what's going to happen on the next question. They're going to ask, what's the measure of angle NQL? Well, NQL is down here in the lower left-hand corner, which means it's 80 degrees. All right, we'll speed up a little since we have most everything we need. Question 15 asks us for angle MNQ, which is the one in the lower right. We already said that's 100. So sometimes it's just nice to fill in the information and see where it takes you, and sometimes you need it and sometimes you don't. The last question is a little tricky. Last question is the measure of angle LMQ. So LMQ is actually the angle in the upper right corner here, but it's not the whole angle. And this is where we have to use property number 1. Now, it may not feel like you're using property number 1 because number 1 talks about sides, and this is asking for an angle. But if I were to draw the top and the bottom parallel to each other, and then what if I drew segment MQ as a transversal? You now have alternate interior angles. Again, we're pulling all the way back to those parallel lines from our unit 2. And down here in the bottom of the diagram, it tells us this angle is 29 degrees. And so this angle up here is also 29 degrees. And so that is the answer to that one. And that is it for the example. So your homework over the next couple of days is section 5.4. And remember, this is not from your Big Ideas textbook, so don't try to go to it and find it because chapter 5 is actually congruent triangles. But for the sake of what we're doing, it's section 5.4, numbers 1, 2, 5, 8, 10, 12, and 19. I'm going to warn you, some of these are easy, some are difficult. Number 19, you're going to have to solve using systems of equations. I know how much you guys love that. And then you've got a ratio problem, number 8, and just a nice variety of problems. We'll talk a little bit, maybe the next video I do on number 5, how to prove that that's a parallelogram using coordinates. But for right now, I think that should suffice. So this will be the video for Thursday. Please work on the homework, and then we will post this and talk to you guys about the homework and what to do next on Friday. So hopefully this helps. And if you have any questions, feel free to contact us.